Hello everyone, my name is Samuel Le from Aalto University, Finland. I will be presenting a paper titled Sponge Sequence Planning with Deformable-On-Rigid Contact Predictions from Geometric Feature. In this work, we propose a sequence planning pipeline called Sponge that aims to provide robots with task planning skill in order to efficiently automate downstream deformable objects manipulation tasks, especially those that involve interaction between volumetric, deformable, and rigid objects. The proposed planning pipeline consisted of two important steps. First is to learn to predict the contact between the deformable tools and the rigid target objects, which is then used for sequence planning where we aim to generate an optimal trajectory to perform a manipulation task. Let's now go into a bit of the detail of this steps. In the contact prediction modules, we propose using a dense point cloud network to model the contact information between the deformable tool and the target objects. Specifically, we use a point net segmentation architecture, which, given an input point cloud of target objects and the pose of the deformable tool, it produces a per point contact class, which indicates whether a point of the contact objects is in contact with the deformable tool or not. We explicitly address the problem of area coverage planning under deformation. To achieve this, we leverage the learned contact prediction model to plan an optimal trajectory that covers the entire surface of the target object with the minimal travel distance. We investigate the performance of the pipeline in the real world by conducting an experiment to perform a disk cleaning task with a Frankel robot. The objective is to clean all the blue marker writings. From the result, we can see that even though there still remains some blue marker, the robot has successfully accomplished the task by removing about 90% of the blue marker writing from the surface of target objects. Thank you.